Okay, so thanks a lot. Thanks for the organizers for putting our paper on the program. This is joint work with Valentin at UCLA. I want to start with the research question that we're after in the paper. The research question that we're after is how much variation in aggregate risk premia can we ascribe to intermediaries rather than to households? Okay? The two keywords I want to highlight, they're not coming through, they should be highlighted, is aggregate risk premia and this rather than households. So what do I mean by that? Let me make this very concrete with a particular example. Okay? So here's some data in the 2008-2009 financial crisis. I'm plotting a mortgage-backed security spread, a corporate bond spread, default spread, and then the dividend yield on the S&P 500, all kind of measures of risk premia across some different asset classes. And we can see all of those measures spiking dramatically during the crisis. Okay? So one story that favors the kind of intermediary view of this would be financial institutions, think Lehman Brothers or Goldman, got into a lot of trouble during the crisis. They had very severe losses. Their equity was depleted. Their willingness to take risk at that point in time was very low. They faced funding constraints. All of that meant their risk-bearing capacity was impaired, and that's what's driving up these measured risk premiums and causing prices to fall. Okay? But of course, there's another view, right, that aggregate risk aversion of households is probably also moving around at the same time. Okay? We have specific models of that. You could think of a habits model. Consumption is falling at this point in time, so it makes sense household risk aversion would be rising, but we could think of lots of other reasons why households might be scared or particularly risk averse at that point in time. That would be increasing risk premium. Okay? So our goal in this paper, when I say rather than households, is how can we kind of separate these two stories, and how can we ascribe variation in risk premia to this intermediary channel kind of controlling for the household risk aversion channel. Okay? That's going to be the goal. Now, there is an empirical literature already on intermediaries and asset pricing, as well as a theoretical literature. So far, let me just point out what's been done. We do have some facts that aggregate prices look consistent with a role for intermediaries. Okay? I've done some work on this. Ziguo has a paper on this. Valentin has done some work on this, that intermediary balance sheets predict future returns, so that there's a much longer literature than what we're citing, but we thought we would cite our own papers as examples. So we have this aggregate evidence that's consistent with the role of intermediaries, but it's not ruling out this other possible view. Okay? Now, at the same time, we also have local evidence that intermediaries cause changes in prices. One example would be arbitrage opportunities that are directly related to regulatory constraints or other constraints that intermediaries face. So this Tepper-Vertelen paper on covered interest parity is a really nice example. There's lots of other examples here. Again, we cite a lot more examples in the paper, but here are just a couple. Okay? So again, we know that they might matter for these kind of local prices or these particular arbitrages in time, but again, that doesn't tell us necessarily how much they matter for the aggregate. Okay. So how are we going to go about trying to answer this question? What we're going to do is we're going to write down a model, and the model is going to nest. It's going to be a simple model that nests the two main views. Okay? It's going to allow for a role of household risk aversion changing around over time in sort of whatever way you want, and intermediary risk aversion possibly changing over time. And then we're going to design a test for whether or not intermediaries matter, and the test is going to try to help us understand how much of this variation we can attribute to these institutions. Okay? And the test is going to be to try to document a differential elasticity of risk premia to an intermediary risk aversion shock, or some proxy for an intermediate risk aversion shock, in more intermediated asset classes. Okay? So it's going to look at asset classes that are more dominated by financial institutions, let's say credit default swaps, versus, let's say, the S&P 500. And it's going to say, when intermediary risk aversion changes, it should affect the more intermediated assets more than the less intermediated assets. Okay? Intuitively, these intermediary shocks are going to matter more for assets that are difficult for households to sort of invest in on their own. That's going to be the intuition. And this allows for a positive correlation between this intermediary risk aversion or intermediary health and whatever this unobservable household risk aversion is. Okay? It's going to allow for that, and it's going to help net it out. Okay? So then I'll show you evidence comparison across various asset classes that shows support for the impact of intermediaries across a few different asset classes. And I'll talk about going beyond the assumptions of the model as well. Okay. So let me highlight two of the main facts that we have. So first, I'm running a regression of excess returns on a particular asset class on some proxy of intermediary risk aversion, which I'll get to in a second. I'll talk about this normalization in just one slide as well. So we have stocks, bonds, options, sovereign bonds, commodities, FX, and CDS. I'll show you some additional returns and some additional evidence in a little bit. And you can see more predictability in terms of the R squared for all of these other asset classes from this intermediary variable relative to what we see for the S&P 500. Okay? So I'm going to use kind of the difference in that predictability. We're also seeing really large numbers for some of these R squareds across these different asset classes. So we put this R squared on a log scale, otherwise it's really hard to see what's going on with stocks. The impact that we're going to ascribe to intermediaries on predicting returns for an equal weighted portfolio across these asset classes is about 4.5%. I'll tell you how I get to that number too. Okay. Now, at the same time, in this regression, I'm also going to look at the coefficients across these different asset classes. And what I've done here is these excess returns are all divided by their unconditional average. So this is the sense in which this coefficient here is like an elasticity of the risk premium to this intermediary shock. And the model is going to directly say that this risk aversion change should have a much bigger elasticity in these more intermediated assets less compared to stocks. Okay, so we're going to use the difference in the magnitude of these coefficients over here relative to what we see in the stock market. Okay. So let me go into the model. So the model is relatively simple. It's a two-period model. We're going to have n assets, but for the picture here, I just have 2. And there's going to be a household. The household's going to have risk aversion gamma H. There's going to be an intermediary, which is fully owned by the household. It's going to possibly have risk aversion gamma I, which might differ from gamma H. I'll come to this in a second. For now, just think of 2 assets. Okay? And the intermediary can invest in either of these assets in a frictionless way. Okay? So it can buy or sell either of these assets. Now, the household can invest directly in either of these 2 assets, but it's going to pay a cost, C1 for asset 1 and C2 for asset 2. Okay? We think of this as something complex like credit default swaps versus the S&P 500. Think of this cost as being really low for the household doing this directly, and this cost as being really, really high. Okay? Could be infinite even for some asset classes. Then the basic intuition of the model is how can I tell an intermediary risk aversion shock kind of apart from this household risk aversion shock? Well, if you shock the intermediary's risk aversion and this cost is really high, it's going to show up a lot more in this asset than this asset. Okay? Households are going to be able to kind of go around and invest in this asset on their own, buy it if it becomes cheap, and therefore the price of that asset won't be affected. And that relative difference is what we're going to be exploiting in our empirical implementation. Okay. So that's the whole idea of the model. Let me go into the details. So both households and intermediaries are going to be CARA, risk aversion for households gamma H. They're going to take intermediary decisions as given, and then assets are going to differ in their ease of access for direct investment by households, the intuition that I just gave you. They're going to face these quadratic costs C. Okay? Now, the household's demand for directly owning the assets is DH. They're going to take into account the fact that they're going to have some exposure through the intermediary. So they're going to take into account that they own the intermediary. So the household is exposed to like all the aggregate risk here. Okay? The only thing that's different here is this quadratic cost C down here. Okay? And that's what's going to generate potentially a friction. It could be 0 for some assets and very high for other assets. Now the intermediary is going to have risk aversion gamma I. We're going to allow for the fact of gamma I to differ from gamma H. I'll come back to that in just a second. but intermediaries are going to invest on behalf of households, but they might make decisions that are not exactly what the households want them to do. Okay? And that's where it's going to be important for gamma I to potentially differ from gamma H. Okay? That's all that's really capturing. So the intermediaries demand optimization problem is going to be very, very straightforward. Okay. So what is this going to look like? The intermediary, since he can invest in all the different assets frictionlessly, is going to just choose the mean variance efficient portfolio. That's DI star. Okay, that's obvious. What's the household going to do? Well, it's going to have standard mean variance demand, except for there's this quadratic cost C, okay, because they have to pay these different costs depending on the asset class. And they're also going to subtract off the fact that they own some of the asset through the intermediary as well. Okay? And so they might actually be undoing a lot of the intermediary's decision if that cost is low enough. Okay? So the intermediary could do some crazy thing. If it's costless for the household to sort of undo that, then that's exactly what they're going to do here. And we're capturing this by this derivative of the household's demand with respect to the intermediary's demand there. Okay, so just putting those two together using market clearing, we get the equation at the bottom, which is exactly what I have at the top of the next slide. So I don't know if it's supposed to show up red, but it doesn't look very red to me. The part that's in red is all of this that's in parentheses. Okay, so that's what I want you to take as being very important. So what's it going to mean for the intermediary to matter in this context? We're going to need both gamma I different than gamma H. They're not doing what the household wants them to do sort of all the time. And we're going to need some of these costs at least to not be zero. They're all zero. The household can just undo whatever the intermediary does. Okay? So we kind of call these imperfect substitution. That's C being bigger than 0. Okay? The household won't perfectly substitute away from the intermediary and undo their decisions. And this preference misalignment. So here in the model, we just have this wedge exogenously, kind of that these risk aversions could be different. Marvin's paper with Ziguo or Brunnermeyer-Sannikov or a number of other papers talk about how you might get some of these wedges, right? They talk about why it is that you might get this kind of preference misalignment, and they essentially assume this imperfect substitution, right? They essentially assume that the household kind of can't invest in these particular assets. Okay, so now notice if either gamma I was equal to gamma H, this whole term right here would collapse to the identity matrix. If that were to happen, we'd have the standard thing of the risk premium is equal to gamma H sigma S, right? So that's the standard frictionless case. And same thing, if C were equal to 0, this whole thing would collapse to the identity again, and we understand what's going on there. Okay, good. So that's the model. Now let's think about what the test would be that comes out of the model that helps us kind of decide whether intermediaries matter and decide how much of, when we have household risk aversion affecting prices versus intermediary risk aversion. Okay. So I want to talk about the existing tests that we've done so far a little bit first and why those aren't fully sufficient to sort of answer the question that we're after. So the first test is basically looking at the intermediary Euler equation. That's what I've done in previous paper. Ziguo with Brian and Asaf have a paper doing this, which is an important step, but the intermediary's Euler equation is always holding, since they're always choosing the mean variance efficient portfolio, regardless of what these costs are, and regardless of whether gamma H is equal to gamma I. So just knowing the Euler equation holding isn't necessarily telling you that they matter yet. Okay? Now you could also run a time series predictability test where you regress returns onto some state variable that you think captures intermediary risk aversion. But the problem there is how can you separate out gamma H from gamma I, right? If your proxy for intermediary risk aversion is correlated with household risk aversion in some way, you're never really going to be able to tell that apart. Okay. So our approach is going to be this relative predictability. So we're going to kind of use the variation that we think is in these costs in the cross-section, or really variation in sort of access to these asset classes in the cross-section. So some assets like CDS, for example, are going to have really low household substitution relative to, say, the S&P 500. That's what we're going to be using. Okay. So what is our test going to look like? Well, formally in the model, what we're doing is we're taking the elasticity of the risk premium for asset I with respect to an intermediary risk aversion shock. And you can show in the model that that's equal to CI divided by this other term. It's going to be greater than or equal to 0. It's going to be equal to 0 anytime C is equal to 0. Okay? So if the cost is equal to 0, households can kind of go around and undo whatever decisions intermediaries did. Any shock to their risk aversion is not going to matter for equilibrium risk premium. Okay? Now, on the other hand, the elasticity of the risk premium with respect to gamma H, this is also going to be a positive number, but notice C is not going to be showing up in the numerator. So again, if you only have one time series and you're worried gamma I and gamma H are correlated, the coefficient is going to be positive regardless, so you can't really tell those two apart. But if we had many assets with different C's, we can use that to tell this apart from this. Okay. This one is increasing in C, and this one is decreasing in C. Okay. Okay, so this is in the frictionless case here. Any shock to risk aversion, household risk aversion, is going to affect the risk premia of all assets proportionally. Okay? Just multiplies that covariance matrix, so the risk premia of every single asset is going to go up by the same percentage amount. And in this alternative case, where intermediaries do matter, and here I'm assuming some cost C2 that's bigger than C1, when you change intermediary risk aversion, you're going to have a big effect down here and not so much of an effect here. Okay? Now, one thing we're not going to be able to tell apart is the effect of intermediary risk aversion in the least intermediated asset. Okay? In the least intermediated asset, we will no longer be able to tell apart whether or not C1 is actually equal to 0 and intermediary and household risk aversion are correlated with each other. Okay? Or whether or not it is really intermediary risk aversion driving things. So it's always going to be relative to the least intermediated asset. Okay. So let me show you the evidence. We're going to have a panel of asset returns. I'm going to have some time series of intermediary risk aversion. I'll talk about that in just a second. And I'll come back to some of these other assumptions. What if there's time variation in risk, time variation in the sigma? How do we address that? And we're going to assume that these costs, the ease of access of different asset classes is going to be invariant over time. Okay. Good. So the returns that we're going to use, we're going to try to look at broad asset class categories. We're going to look at stocks, bonds, sovereign bonds, commodities, CDS, options, and FX. We'll also look at some returns to other returns that we think would be useful here. Returns on convertible bond arbitrage hedge funds, fixed income arbitrage, other various hedge fund strategies that we think would have a low substitution rate for these households. Okay? Now, this intermediary risk aversion variable, we need to take a stand. Again, this paper is not saying anything about what the theory is of that's driving this intermediary risk aversion, although there are other papers that are doing that. What we're going to do is we're going to look at the two main factors that people have used in the literature to argue that they proxy for the health of the financial sector in some way. Okay? And we're just going to take an average of basically both of these two factors. I'll show you results, or at least in the paper we have results. I'll see if I get to them where we do these two individually, or where we look at a host of other factors that you might consider. Okay? But all that's important for us is that we're using factors that we think correlate with the willingness of intermediaries to take risk over time, regardless of what the channel is that's driving that. Okay? And then we don't need to take a stand on household risk aversion. but I will show you a couple proxies because the model does have implications for that, and I'll show you what happens when we use those as well. Okay. Now we also need some way of ranking these different asset classes that we're looking at. We want to know ones where we think this ease of access is the lowest versus where it might be the highest. And we use a number of different methodologies. We can't get this for sort of consistently for every single asset class at once, but we tried to look at quantity data from the flow of funds. So intermediaries relative to households are holding fewer stocks, more bonds, more sovereign bonds. We looked at value at risk. So we went to the 10Ks of all the different primary dealers, and they actually spell out what their exposure is to these different shocks, all the individual shocks. So they say, what would happen if stock prices fell? What would happen if interest rates rose? What would happen if commodity prices changed? What would happen if exchange rates changed, and so on? You can use that to try to get rough exposures to these different asset classes. Again, we don't have all of them, but this gives us one way of ranking it. And then the BIS data on derivatives has basically total positions that are accounted for by broker-dealers and financial institutions relative to everyone else. So we tried to use this to rank these as well. Okay? So this gives us a rough ranking. The thing that we want to probably take the most stand on is that stocks are somewhere on the very left-hand side. Something like credit default swaps would be somewhere on the far right. Okay. So now that we have that in this measure of a proxy for intermediary risk aversion, here's running these regressions where I have the excess return elasticity on this intermediary proxy, and I'm doing this asset class by asset class. If we focus on the annual returns, you can generally see the coefficient here getting bigger as we're moving from left to right. Also more significant. It's only not significant for stocks, but is more significant for the others. And also the R squared generally rising as we're going from left to right. Okay? So more predictability in these asset classes relative to what we see in stocks. That's the picture, just plotting those coefficients to make it easier to see. Okay? Again, generally rising as we're going from left to right. In the model, the elasticity is sort of the cleanest way to measure this, but we also show in the model there's a couple of alternative ways. One is looking at this predictability R squared, which I already showed you. That's also higher on the right-hand side than it is for, say, stocks. And then another measure that we look at in the paper is rather than computing this elasticity, which means we have to divide by the mean return for the asset class, that tends to be a pain statistically, right? Because we have to take into account uncertainty in the mean. So we change that to dividing by the variance of that asset class instead. We have to make more assumptions in the model to get there. You have to assume, for example, that the asset classes are roughly uncorrelated, and you can do this, okay? But it has a lot better statistical properties, especially in smaller samples. This is going to be a lot easier to estimate than the risk premium. And those results generally agree when we do this variance normalization as well. Okay? Okay. Now coming to this predictability that's due to the intermediary, basically the way that we're able to do this is take the coefficient that we get on asset class I, subtract off the coefficient that we get for stocks, the least intermediated asset, and then we're looking at the percentage of the R squared that is attributed to this intermediary risk aversion shock. Again, this is kind of a lower bound, right? Because it's assuming all the variation in risk premia in stocks is really just because of this correlation with household risk aversion. Okay? So it's a lower bound in some sense, if you want. Another way to say that is we're assuming that the cost for stocks, the C, is equal to 0. If that were not true, then these numbers would be higher. So we do that both for this elasticity measure and then the coefficients using this variance normalization. And then what you could do is you could sort of add up all of these different numbers. That was that aggregate number that I gave you of about 4.5%. That's just basically equal weighting all these different asset classes and saying how much of the variation in risk premia aggregated across those asset classes can we reasonably assume to be driven by intermediation rather than household risk aversion. Okay. There's a lot of robustness in the paper. If you have the link on the program website to the actual paper, these are the tables where all these different robustness checks are performed. So one thing is testing differences in these coefficients. So are they statistically different from each other? Are the coefficients statistically larger for different assets than they are for stocks? We talked about this in table 4. Again, that's harder for the elasticity measure because of this uncertainty about the mean. It's much more better behaved for this variance normalization. Different samples, dropping the crisis, things like this is in table 8. Alternative measures for intermediary risk aversion, looking at the measures separately, looking at levels instead of changes. We look at this Gilchrist-Zakrajcic spread. Other ways to proxy for the health of intermediaries. Okay. Time-varying risk as well. We try to control for time-varying volatilities and time-varying betas in all these different asset classes. That doesn't really change the results much either. Okay. Now again, none of what I showed you relied on being able to measure household risk aversion, but we do think that it's useful to show what happens when we have a proxy for household risk aversion. So here we're using CAY. Now remember, the model predicts that the elasticity should be decreasing in C. So now it should be highest for the least intermediated assets and lowest vice versa for the ones where they're not participating as much. And this is basically exactly what we see. So here are these elasticities when I'm using CAY now as a proxy for gamma H. And you can basically see they're roughly larger for stocks than for the other ones, and generally speaking, declining. It's not perfectly monotonic, but generally that's what the picture is. This is just showing that in a table, so I'll skip through this since I think I'm running low on time. Time-varying risk, so what about changes in sigma rather than changes in either of the two risk aversions? So what you would need for this story to work is more intermediated assets would have to be more risky exactly the times when intermediaries would be getting into trouble. Okay, so that's the story you would need for this to work. We can't perfectly deal with the story, but what we basically do is we look at controlling for rolling volatilities of each asset class and then rolling betas for each asset class, both of those as controls, and we find that the results don't change too dramatically. I probably only have a couple of minutes. So let me say a couple more things. So we also expect this to matter more for sort of more complex strategies where the average investor would have a harder time investing in. So we look at a couple of additional things. So we look at convertible bond arbitrage. That's something we would think definitely intermediaries would matter, whereas a regular investor would not be taking advantage of. And fixed income arbitrage. Both of these, there's kind of event studies that are very suggestive that intermediary capital would play a role here. So let me show what the evidence there looks like. I won't talk about these other hedge fund returns, but these are the convertible bond and fixed income arbitrage hedge fund returns. So I'm doing the same predictability exercise. Here's the stock market or S&P 500 on the very left-hand side. You can again see larger coefficients for these, more predictability in terms of the R squared, and then the same thing when you use this different normalization. 1 minute. Okay. Same thing again, if I use CAY or some proxy for household risk aversion, we also use this Michigan sentiment measure. We don't get this. We get a high coefficient for stocks and we get lower coefficients for all the other ones, less predictability, et cetera. Okay. So let me conclude here. So the question that we're after, do intermediaries matter for aggregate asset prices? Our answer is yes, a lot. Okay. We try to design and implement a test that takes this household risk aversion view very seriously and tries to think about how we could separate these two channels. And the main evidence and what comes out of the model for the test is if intermediaries matter, the risk premium of intermediated assets should respond more to intermediary shocks or intermediary health. Okay, I am out of time, so thank you.